Okay, let's get reviewing. Here we go. Let's get reviewing. Tomorrow, just a quick recap of what you can expect on the test. There's only going to be 12 questions on there, 38 points. And I realize that is not much for a unit test, but I can't make this test longer than it needs to be because no one would be able to finish in the amount of time you have. All right, so that's why it's only 12 questions, 38 points. You guys already know there's going to be one proof on there. It's going to be coordinate geometry, and it's going to come strong. It's just not going to be, hey, prove to me I'm a parallelogram. It's going to be more than that. So be prepared for that, please. The other 11 questions, here it is. All right, I didn't want to put a statements reasons proof on here because you've done enough of them during the year. All right, you've had enough exposure to statements and reasons. Here's what I wanted to do specifically on this unit test. And here's what the other 11 questions are going to apply to. Here is a figure. Here's the angles or the side measures. Find this. And you're going to have to know the darn properties to be able to set up an equation for it and then solve it. That's what the other 11 questions are. I'm going to test you on every single quadrilateral we've talked about. Here's a kite. Here's what I'm going to give you about the kite. Find this. And you got to know the properties to solve the equation. You got to know the properties to set it up. And when you solve a couple of the equations, one of them you're going to have to factor to solve it. That was on your quiz. Some of you guys just said, you know what? Forget you, Mr. Carlino. I'm not going to worry about factoring. And it showed. Because you had no clue how to factor. I'm telling you, it's on there again. So do something about it in the next 24 hours. Do something about it. And then one other question. You're going to have to solve your equation. And at the end, your answer needs to be in simplest radical form for me. So you're going to have to break down a radical at the end. Those are the other 11 questions. Very straightforward. Here's your figure. Do you know enough of the properties to be able to set up the equation and solve? So some of you guys that have been lazy during this unit, I feel for you tomorrow. You got sympathy for me because it's going to be rough for you guys that have been lazy during this unit and have not put in the honors level effort on the homework. It's going to be brutal tomorrow for you, and I have sympathy for you. Sorry. All right, what can you do to review? Here you go. I have multiple opportunities and questions for you guys to review on your own because today I am not going over any review questions. I will show you in a minute what my plan is today, but I am not going to go over any review questions. There's not going to be time. At the end of your packet pages 48 to 53, there's a slew of questions with the answers in your packet as well. All right, 48 to 53 has got a ton of quadrilateral questions with the answers in the back. On Classroom, what I'm finding out is where you guys struggle on our tests and quizzes is the multiple choice section. So what I did on Classroom, if you're interested, there we go. Under quadrilaterals, you will see quadrilateral test, extra practice. These are all multiple choice questions. All multiple choice. In fact, I think I put 35 of them on here that deal with quadrilaterals. I just want to make sure. I don't want to misquote myself here. Yes, 35 multiple choice questions with the answers followed by it. All right? 35 on there for you if you want to get after it a little more. So extra practice there. And then in your packet, there's some problems we never got to in class. So if you want to try those as well, that might be a good idea. So a lot of different opportunities for you guys to try out problems. Any questions about the setup of the test before I actually get into what my goal for today?
Are there any, is there anything anywhere for factoring practice? Like, are there any questions?
I can put, I do have some, I can put them up there if you'd like. Also, I would highly recommend looking over your quiz question that involved factoring as well. Okay. There was a question on your quiz that you had to end up factoring, and it's something similar to that tomorrow. But I can put that up later today. Anything else here, guys, about the setup? All right, here's what I'm doing today with you. I think it is not worth going over certain examples in your packet or on Google Classroom. So what I'm going to do instead is we are going to go figure by figure today and write down the properties. And then after I do that, The second thing we're going to do before we leave today is we're going to go back to those figures and say, if I ask you to prove this on the coordinate proof tomorrow, if I ask you to prove this figure, how are you going to do it? What formulas do you need? So that's my goal today. Go over all the properties and then set up scenarios where, what if I asked you to prove this figure? How would you do it? What formulas do you need? And then I'm done. All right? So let's get this started. Now, I want to just let people know that you do not feel pressured to write all this down. Do not feel pressured to write all this down. I wrote all this down first period, made a PDF of it, and it's up on Classroom right here. You guys can see on your screen, class notes. All right, from today, class notes. These are all the notes I'm about to take. Okay, so don't feel pressured to write down all the properties. If you want a little study sheet, you can just go on Classroom and download that PDF that's got all the properties I did first period. All right? But what I do need your help in is open up your darn mics and tell me what the properties are, because I do not have time to do numbers today. It's just going to waste my time. Just going to slow me down. All right, let's do this. This unit started on December 10th. And on day one, we did not talk about any quadrilaterals. We talked about interior and exterior angles of polygons, which will be represented tomorrow on your test. You will see a question on that. So here we go. Sum of the interior angles is equal to, let's do this. And I don't want to hear the same voices. Let's go. Chime it in. Even if you talk over each other, it doesn't bother me. Let's go. Sum of the interior angles. What's that formula you're going to need for tomorrow?
180 times n minus 2.
N minus 2. And remember, n represents the number of sides in the polygon. 180 times n minus 2. All right. What about, let's go outside the polygon. What about the sum of the exterior angles? What do you got for me there, kids? 360. I don't need a formula. It doesn't matter the number of sides. It's always 360 degrees, the sum of them. And then finally, make sure you guys know, if this term pops up tomorrow, what a regular polygon is. Regular polygon. All sides congruent. All interior angles congruent. All exterior angles congruent. Okay, that is a regular polygon. All right, so I didn't want you to forget about that because that was way back on December 10th we did that. Believe it or not, we were actually in school when we did that. All right, let's move. Parallelogram time. I got 5. You got to know. 5 for tomorrow. What do you got, kids?
Diagonals bisect each other.
Diagonals bisect each other. Keep going, even though I'm writing. I can listen and write it.
Sides are parallel.
Yep.
Opposite sides are congruent.
Opposite angles.
Opposite angles congruent.
I heard 4 of them. I need one more. I'm looking for one more I didn't hear.
Consecutive angles are supplementary.
There you go. Opposite sides parallel. Opposite sides congruent. And the one that was just missing but said, consecutive angles supplementary. Some of you guys messed up on that one on the quiz. Take a look back at your quiz, please, if you have to. Some of you guys told me the consecutive angles were congruent for some reason. All right, consecutive angles are supplementary. Good work. So there's your parallelogram. Let's move over to the rectangle. I can't stress this enough. Do not forget the rectangle has all parallelogram properties. So those 5 we just went over, the rectangle has. And again, this is up on Classroom if you want a study sheet. Let's see, you need, right, diagonals. Okay, 3 more properties of a rectangle that only apply to the rectangle. Anybody got something here for me? Let's roll.
All angles are right angles.
All 4 right angles. It's equiangular. Diagonals are congruent. And here you go. I'll help you guys with the last one. Because the diagonals are congruent and they also bisect each other, the diagonals create 4 isosceles triangles. Okay? When you draw both diagonals in a rectangle, it creates 4 isosceles triangles, which means the angles across from the congruent sides are congruent. That's where that property helps you. Any questions on parallelogram or rectangle before I move on? All right, let's go to the old rhombus. I'll start rhombus off the same way I did rectangle. All parallelogram properties. Let's see how many, I think 3 more special, yep, 3 more rhombus properties that only apply to the rhombus. What do you got?
Consecutive sides.
All sides congruent.
Yep, there you go. It's equilateral. All sides congruent.
Diagonals are perpendicular.
Okay, diagonals are perpendicular. And let me stop right there before somebody gives me the last one. Because the diagonals are perpendicular in a rhombus. All right, let me just draw a quick little rhombus out here. I like seeing it better than talking about it. Okay, my little rhombus here over to the left of your screen. Let me draw in the old diagonals that are perpendicular to each other. All right, because the diagonals are perpendicular, you should see 4 right triangles inside the rhombus. When you see a right triangle, you might want to start thinking about good old Pythag. Okay, so just a little heads up on that for tomorrow. Diagonals of a rhombus are perpendicular. They form 4 right triangles where you can do the Pythagorean theorem. All right, so just a heads up. And then final property, anybody? Something else about the diagonals?
Diagonals bisect the angles.
Correct. Diagonals bisect the angles. So on my diagram right here, these 2 would be equal to each other right here. All right, diagonals bisect the angles. Questions from you guys?
This is a bit, I don't know if this is going to matter on the test tomorrow, but can you use the word bisect to refer to bisecting a line too?
You can use bisect for a line or an angle. Yeah, they both work. You can bisect an angle and bisect not a line segment. Line segment. Yes.
One second.
Yep. Yep. All right, everyone, good on the old rhombus. All right, here we go. Square. I'll make this easy. All rectangle properties. It's got everything, remember. Which makes it easy to remember, but hard to work with because it's got so many properties. And yes, there will be a square question tomorrow. Highly recommend you look back and look at any square problem we did in the past that involved some algebra. All rhombus properties. Okay. Properties, square, you know, it's deceiving. Doesn't seem like it's much, but because there's so many properties, you can use them so many ways. Any questions on the parallelogram family before I get to the trapezoids? All right, trapezoid time. I made a note for myself here to remind you about, make sure you know what a midsegment is. Make sure you know the facts about a midsegment. And we just went over that 24 hours ago. All right, midsegment. And if I could spell it correctly, why don't we take that E out of there? How about that? There you go, midsegments. So make sure you're aware of a midsegment. Parallel to the bases, and the length of a midsegment is half the bases added together. All right, trapezoid property. There's only one. One pair of opposite sides parallel. That's it for a trapezoid. One pair of opposite sides parallel. All right, isosceles trapezoid. A little bit more to it, a little bit more. You still have one pair of opposite sides parallel.
Legs are congruent.
Okay, I'm going to write this. Non-parallel sides, which, yes, are called the legs. Make sure we're aware of that. The non-parallel sides, the legs, are congruent. Perfect. I'm looking for
Base
two.
angles congruent.
Yep, base angles congruent. And in an isosceles trapezoid, remember, there's two pair of base angles. Two pair. I'll put it up. I might as well throw it up here so you can visually see what I'm talking about. Two pair. The top pair and the bottom pair are considered base angles. All right? And there's one more property be aware of. Diagonals are congruent. They do not bisect each other. They're just congruent. That's it. Don't make them anything else. The story ends that they're congruent. That is it. Both diagonals are equal in length. Anything on our trapezoid work here? Anything on our trapezoids you want to ask? All figures will be tested tomorrow. I'm guaranteeing it.
So on the regular trapezoid, the parallel properties apply to the isosceles trapezoid, right?
The what was that?
So the isosceles trapezoid, that also has one pair of sides parallel?
Correct. Yep. If it's an isosceles trapezoid, it has any properties the trapezoid has. Anything else here, guys, before we go to the last one? You know what's coming up.
And if you're given a shape that looks to you like a trapezoid, and it says that, and there's like markings, or you're able to figure out somehow that the legs are congruent, then you would know that that either the legs are congruent or the base angles are congruent. If you can figure one of those out, you know that it's an isosceles trapezoid from there.
Yes. Yep. And tomorrow I'm just going to come out and say in the directions it's an isosceles trapezoid. It's a rhombus. It's a rectangle. Okay. There won't be any guessing games there tomorrow. I'm just making sure you guys, did you study your properties and can you apply it to write an equation? All right, here it is. Let's finish it off with the good old kite. As we know, kite, I just put the first property on there with the markings. Two pairs of consecutive sides are congruent. Spell that correctly too. All right, what else you got for me? Kite.
The longer bisector bisects the shorter diagonal.
There you go. Longer diagonal bisects the shorter. I got two more I'm looking for here.
Diagonals are perpendicular.
Diagonals form right angles, correct. They're perpendicular.
One pair of opposite angles are congruent.
Yep, and let's talk about that, where that one pair is. One pair, only one pair.
Formed by the non-congruent consecutive sides.
There you go. One pair of opposite angles congruent. Now, where are they? Because look, your kite may not look like this. Maybe it's rotated 90 degrees. Maybe it's flipped upside down. You never know. But you can always find the pair of opposite angles that are congruent by where the two non-congruent sides are joined. All right, so find two non-congruent sides where they meet up. Here's one angle, and here's the other opposite angle. All right, it's formed by the non-congruent sides. And if you want to think about it, if you do struggle, if I do draw in the longer diagonal, those two triangles I've just created are congruent by side, side, side. So by CPCTC, those angles have to be equal. Okay? So think about where the longer diagonal is, and then those angles and those triangles would be congruent. All right, there we go, kids. There's all our properties. There they are. Any questions on the properties?
Doesn't the kite Doesn't the longer diagonal also bisect the angles? Like, is that considered a property or just something you can figure out?
It is a property, Sophia. I just didn't want to throw in a fifth one because you guys have so many to remember. But again, just like I have the two triangles up here are congruent by side, 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 you can now say CPCTC says these two are congruent, and then these two down here are congruent. So yes, you could make a property up that said the longer diagonal bisects both, but you could also just get that from saying, hey, the triangles are equal, so by CPCTC, those angles are equal. I just didn't want to add in more and more properties for you guys to stress about. Anything else here on the properties? All right, let's move it then. Let's keep trucking. Now what I'm going to do is I'm going to go through each of those figures again, and we're going to talk and say, if I ask you to prove this on the coordinate proof, how are you going to do it? What formulas am I going to need? And again, this is all up on Classroom as a PDF. All right, so let's start with the parallelogram. I won't ask anybody this because we went over this yesterday in class. How would you show a parallelogram on a coordinate proof? It's your choose your own adventure, right? Choose your own adventure. You could go opposite sides parallel, slopes. You could go opposite sides congruent, distances. I don't know how many of you would do this, but it's an option. One pair of opposite sides congruent and parallel, so you would need slopes and distances. All right, choose your own adventure there. Have a plan tomorrow. Well, could I ask for a parallelogram? Sure, but you can probably expect some other stuff to be asked. I'm just not going to ask a parallelogram. There's probably going to be some more to it if I do. All right, let's keep going. How about a rectangle? What's the best way in a coordinate proof to prove a rectangle? Show it has 4 right angles. Okay, show it has 4 right angles. That's what I would recommend. And that's the way we did it in your notes. Okay, show it's got a right angle. How do I do that, guys? Anybody? What formulas am I going to need?
Slope formula.
Yep, slopes. And I'm just going to put in little brackets here to remind you, you need negative reciprocals to get the right angles. Okay, so that's how I would prove a rectangle. You find all 4 slopes, see if they're negative reciprocals, lines are perpendicular, you got right angles. All right, rhombus. Easiest way to prove a rhombus on a coordinate proof. All 4 sides equal, done. All 4 sides are equal, done. What formula am I going to need to do that?
Distance.
There you go. We need the distance formula to do that. Any questions so far? How I would prove a parallelogram, rectangle, or rhombus tomorrow if I was asked. All right, square time. Go ahead.
No, never mind. I figured we'll get to it at some point.
Okay. Square. Yep. This one involves a lot of work. There's actually 2 ways. 2 ways you could do a square. You ready? I could do a rhombus, which we just talked about, prove all 4 sides. With, anybody what makes a rhombus into a square? Show a rhombus has a what?
Right angle.
1 right angle. So yes, you would need both slopes and distance for this one. I don't think you're going to get away with just doing one here. Slopes and distance. Everyone good on the first way to prove a square? Slopes and distance, show it's a rhombus, and then show it's got a right angle. Or, if you're not feeling in that way, you could show it's a rectangle. So show it has 4 right angles. So I could show it's a rectangle with, anybody, what makes it into a square? A rectangle with?
2 consecutive sides congruent.
You don't need to show all 4. Just show me 2 consecutive sides congruent. All right, there's your square. Two different ways to do a square. So again, yes, you would need slopes and distance again. So you're not going to get away with it just doing one formula for a square. It's just a matter of what are you going to prove it first, a rhombus or a rectangle first.
But basically, you need to prove that it is one rhombus property and one rectangle property.
What do you mean by one rhombus, one rect? The first thing you, regardless of which way you choose, you have to show it's a full rhombus or a full rectangle first. And then you can show it has one of the other properties, yes. Like to show it's a rhombus, you just can't tell me the diagonals are perpendicular and you're done. You got to show me it's got 4 congruent sides. Whew. We all right? And then finally, how am I going to prove the trapezoids? So tomorrow, first proof says, hey, prove this is a trapezoid. What's our plan of action here? Prove slope. Yep, that's the formula I'm going to need. What do I do with the slope? One pair. Go ahead.
Like one opposite sides parallel and the other one not.
Okay, good. One pair of opposite sides parallel. But if you guys stop there, it's not a trapezoid. You need to show other pair not parallel as well. And you can do that by slopes. Remember, parallel lines have equal slopes. We did a trapezoid one at the beginning of class yesterday. Beginning of yesterday's notes, day 10, we did a trapezoid proof. And then last night on your homework, you guys did isosceles trapezoid for me. Which is slopes and distance. All right, why slopes and distance? Well, you still need to, I'm just going to draw an arrow over here, still need to show it's a trapezoid. And then what else would I need to add on to my proof after I show it's a trapezoid to make it isosceles?
Legs are congruent.
Yep.
Non-parallel legs are congruent.
Yep, the legs are congruent, and that's where the distance comes in. Whew. There we go. Any questions at all there? That's what I wanted to get through today.
What about kite?
Oh yeah, we forgot about the kite, right? And I don't know what happened on my drive to school today. Maybe some of the ice melted off my small heart that I have, but I'll just let you know it won't be a kite. All right, I'll give you that inside information that it won't be a kite. So we're not going to go over the different coordinate ways to prove a kite. But you darn well know kite's going to be on the test, and you're going to have to do an algebra problem involving a kite. So those properties we just spent some time doing, you better know those down cold, because that will still be on there. The kite is not going to be forgotten. Anything else? All right, so you guys have choose what you're doing here. You can go to the packet questions. You can go to the multiple choice, the 35 multiple choice I put up on Classroom, or try any problem that's not complete in your packet. Your call here for the next 6-7 minutes. We're not signing off. Just letting you guys know, reminder, Unit 7 starts on Friday. The packets are at the main entrance of the high school. If you want to swing by and get a packet before Friday so you can take notes in an actual packet instead of on your Chromebook. Front entrance of the high school. And yep, I'll be after school today to answer more detailed questions if you have them. But for now, let's get moving on some of these questions. Know your darn properties or it's going to be brutal tomorrow. Where'd you go? There you go. All good? All good? Okay, any issues? You submitted it? All set? All right, good deal. Thanks, Jack. I'll see you tomorrow. Yep, bye-bye.
You said that it's in a rectangle where the diagonals create 4 isosceles triangles, right?
Correct. The rhombus, it creates 4 right triangles, which you want to start thinking about Pythagorean theorem in a rhombus. And just again, last reminder, all those properties we just went over, all class, are up on Classroom. Okay, the whole note